I am back where I grew up with two very good friends of mine. I'm very excited to talk to you today. Tony, I've known for over 10 years. Tony Gomes does the kind of diagnostic work that I do in Tampa area. So if you're down here and you need somebody who can do testing extravaganzas, he's your guy. Brad Lemley is my last remaining friend from high school, who I keep in regular contact with. Brad was a mechanical genius. I remember you took apart your dad's truck and took the engine out when you were in 10th grade, and then has proceeded to work on airplanes, and then installed the HVAC system in our tiny lab, and now services my parents' HVAC. Not personally, he runs a company. Thank goodness he finally has employees. We've been pushing him for a while to do that. So now he gets actual sleep, not going out to help little old ladies in trailer parks at 2 o'clock in the morning anymore.
I still do.
You still do? Okay, cool. So uplifting air, Faraday, energy. I'm linking in the notes. What I want to talk about today is we have an opportunity to talk about some interesting new changes that are coming up that I'm a little less knowledgeable about. We have an actual HVAC guy who is stellar and who thinks a lot about this stuff, who has some issues with the way that things are going. And so I want to get your perspective on that. Let's start, Tony. You and I have a client, Nico, who we have a video. He's one of the only guys we've ever met who has a basement in Florida.
Yeah.
And everything was fine in this house. He bought a house, replaced the AC, old single stage, with a variable speed piece of equipment, went away for a month, came back, mold.
Right.
So can you tell us about how that dynamics of that work? Because I think a lot of people would think, oh, a VRF system is better than a single stage system.
In a lot of ways they are, and in a lot of control ways they're not. And what happened in that house was that they had replaced the single stage with the variable system without taking into consideration the house itself. No testing was actually done on the house to see how much the house leaked, where it might be leaking. As it turns out, all the ductwork, which was sheet metal ductwork, was run between floors. The garage on one side and a porch on the other. See, the inner floor space was not sealed at either end. So all the ductwork essentially was running outside because you had flow-through ventilation between the floors. So the system would overcool to meet the humidity number. And because the house leaked enough, the humidity was quite high. So it would roll back both blower speed and compressor and run at a much lower capacity to try to dehumidify. So it was bouncing on the dehumidification set point, which was 3 degrees lower than the actual set point. So that duct got very cold.
For
and
longer.
It was,
for longer. Colder for longer. Instead of turning on, punching the house in the face, and turning back off.
Exactly. And it would just run for hours on end like that while no one was home to notice that we're getting drippy lines on the ceiling and things like that were happening. It was older ductwork. It was insulated to some degree, but the insulation was not particularly well air sealed. And once you get that insulation wet, that just compounds the problem.
Yeah. I think also that the idea that we have, so we've got two different duct leakage tests. One is total leakage, which is what everybody uses now. But we used to have this thing that was much more widespread, which is leakage to outside.
Yes.
And that's only if you know for a fact that all the cavities that the ductwork is running in are totally sealed away from outside, which they're generally not. So you could have ductwork that's inside the enclosure, but still have a lot of leakage to outside because of.
And that test is actually
issues.
if when you do energy calculations here in Florida, if you take your credit for tight ducts, which would be a QN of 0.03 or less, that's a required test. Problem is, local jurisdictions don't really push that. It's there on the form, and it says this test is required because you've taken this credit. And I've said City of Tampa is the only one I've had really say, yes, we absolutely want that documentation.
Yeah.
Really the only ones. Every other jurisdiction I work in, and I work from Hernando County down to Manatee County and out to Polk. They're the only ones that I've had require that documentation, even though it says on the form that it is in fact required by Florida code.
Sure.
So
this is one of the ways that we give the shaft to the HVAC professionals, right? Is we don't really enforce some of the codes on the enclosure side, and then you have to take the brunt because anybody who's watching this and any of your friends and family, anyone you've ever met, they have an odor problem, a temperature problem, a humidity problem in their home. They're calling one person, and it's
your fault.
You. So how does this start to affect you? And by the way, I put out a video about manual J calculations the other day, and I have this like magical world where I work on new construction with people, clients who are you guys, who are all super nerds and are all like thinking about this and trying to plan out your ACH 50. These guys step into existing homes where they're trying to make it better. And so you were like, I don't think 500 square feet per ton is not that outside. 600, we're having a hard time breaking it to 600. So the kind of homes that you're dealing with, the kind of clients that you guys are dealing with, what do you think is the issue where we're going with this performance direction?
Well, like he just brought up, you can have somebody come in and install the air conditioning system or reduct a house, if you want to call it that. They don't get the proper testing, don't make sure the ducts are sealed and everything like that. And the customer or the homeowner never even knows about it until you try to make a change to a freak drive or something like that. That's when the problem shows its face, and all they do is blame the person that put the system in, when the whole time it was actually in the ductwork that was done, years ago that wasn't done properly. It just kind of, for me, it goes back to a lot of times the finger will get pointed at the wrong person when the blame is actually further back. But most people won't pay to have that testing done. They would just rather take the chance than they get mad at the end.
Right.
So that's where I use Tony a lot. He'll come in and he'll get all these things found before we make that mistake.
And I think so that's why I'm always pushing for HVAC guys to take blower door testing seriously. Either do it themselves or have a guy who is the guy that's like, hey man, this house is the problem, not my system.
Yeah.
So there are some changes coming down the pike. And we're in right now, where I grew up in Tampa, Florida, one of the most dangerous climates in the country as far as humidity goes. The way that classic to say it is the dew point of the outdoor air is often, like most of the year, I think, above the indoor temperature that most people keep their set points at. So if any outside air comes in contact with inside surfaces, it gets wet. So what is about to happen with code for you? Let's talk about the HVAC side first.
Well, we are changing refrigerants 3 more months before the mandate on the new refrigerants come in. And from what I'm hearing coming down the pipeline, all the future residential systems that are single stage and dual stage will be taken out, and only frequency drives will be used on the compressors going forward. And once they do that, it's just going to be a whole game changer. All these areas like he's talking about where the ducts are not prepared correctly, everybody doing a change out is suddenly going to be faced with it. They're going to start having the drips on the ceilings and the wet spots and everything, and there'll be nothing that can be done about that other than test and try to fix it.
So last time we switched out here from our, I don't even remember what the
22.
Our 22 to our 410, you could still get the old refrigerant. Are we going to be able, like, when people, are they still going to be able to service old systems, or are we going to be required to be?
No, the systems that are out now, like 410A, is still being sold today.
Okay.
So those have 10-year warranties. They're going to have some sort of either 410A or some aftermarket product they can go in there to blend with it or be changed to finish out the life of your warranties and what you've already got going on.
The phase out time can be quite extended.
Yeah.
And what they do is they'll phase it out slowly, and then they'll stop new production. But any recycled or reclaimed, which you're required to do, will be available beyond that. So that the price will get higher and higher. To buy our 22 now, you'd have to like hawk the kids, do that. You can still get it, but you don't want to know what the bill is.
Okay.
Yeah, I still use it. But one of the things that I've been reading and hearing about on this new refrigerant is, like, when they went from the transition from R22 to 410A, they had a pretty good window knowing this is coming. They had time to prepare. They put a lot of test units out there to see how they would react and start working some bugs out. This came down the pipeline, and this got forced in within like 1 to 2 years. So they didn't have, there's very little testing homes. There's very little areas where the systems got to be tried out with the new gases.
And if they did, maybe they did it in Kansas, which is not going to be the same as how
I'm telling you, there are already a couple of companies out there that have already switched to the new gases, and they went ahead and did it early, and they're having a lot of problems.
Interesting.
A lot of coil problems, a lot of issues with this new gas that are coming up. I'm not going to name products, but they're already having a lot of issues. So I can already pretty much see this mandate in 2 months when they switch it over. All these units are going to change over, and everybody's going to be pretty disappointed, I think, in the outcome of the new machines and how their breakdowns and their problems. I think the warranties are going to be very high.
There's a little more complication with the systems as well, because this is a mildly flammable material, they have to have sensory to detect leak stuff. How do you test that going forward? How do you know it works? You know, and is there some kind of periodic retesting for that sensing equipment? We don't know. 10 years down the road, your house burns down because of something. I mean, granted, this is not like light a match and the whole house goes up. You really got to try to make these burn. But if it's that safe, why all the sensing required? And how does that sensing get maintained over time?
It's
I don't know
not.
how that would work
That's
for
how
you
they're
guys.
pushing it. They got to put these sensors in, but they're really pushing it. It's very low flame.
Yeah.
It's very low to get it to ignite.
Is this the propane-based refrigerant that we're talking about?
It's not really propane based. It's kind of sort of,
Okay.
but not strictly speed. You say propane based, and it's like, what was it when 22 went out? There was one called Free Zone that was just propane. And propane works great as a refrigerant, but it'll blow your house up. But you don't want leaks in that. And then how do you know? You know?
Now that's already being used in refrigerators and freezers.
Oh yeah.
Like it's straight butane or propane. They got one uses
In single-family homes.
yeah, like more than likely your personal one, if you've bought it in the last probably 2 to 3 years, it's already got propane or butane running in it. And that's a different, they have a different number, but it's
But your point is they've tested that, they rolled that out over years. It's a closed system. We don't have sensing equipment that's like, oh, what if it's leaking? And you're saying that what worries you is like, oh, we've got this extra stuff.
your refrigerator or freezer only holds about, they've used microchannel coils that use very, very little refrigerant. So instead of it taking like a half a pound to a pound of gas, now those things are running on like 4 ounces. So even if you had a leak, it would take a lot to get an ignition.
Yeah. Okay. So one of the side effects of this change out of the refrigerator is that everybody's having to remake all of their model numbers and rename all their equipment and get rid of some equipment that was stupid
Because
or
your
whatever.
compressor oils are going to change. POE oil, I don't believe that's what's going to be in these. The oil has to work with the refrigerant that you're using. It's a blend. It's not even like R22 was a single type gas. 410A is a mixture of like 2 or 3 gases. This is the same thing. It's going to be a mixture of gases, so it has to be used a certain way, but it also has to use a specific oil in the compressor. So the compressor has to accept the new oils. Everything has to work on the new system. And
Line set has to be dedicated, like a new
line set.
you can't reuse.
At this point in time, they're saying you're supposed to replace the line sets and for every time, but they said the same thing about 410A, and shortly after they found they could be flushed and cleaned and reused. So right out of the gate, it's going to be a little bumpy until everybody kind of learns.
And it always is when they make these changes. There's always a learning curve. Sometimes it's really steep.
Yeah.
Sometimes not so much.
Right.
But I would expect this is going to be a little steeper than most because of the additional control factor in the equipment and the tech's getting used to that and how that all works. And they're still working on 410A systems and in some cases 22 systems. So now they've got 3 levels of different kind of technology there to deal with. So it's asking a lot of a guy that's out there every day in a truck all day long.
Yeah.
To keep up with this.
You would think everybody's tests are the same. How they field test or how they lab test their condenser and their air handler. That's where I found, because I kept asking myself when I put this particular brand in, how come when I do an exact change out for an exact change out, if the house was borderline big enough to handle the job, when I switched to this brand, how come it won't handle it now? This brand almost always has to go up like a half a ton. And when I started doing more research looking into it, you learn like the condensers are tested in a lab and it's what temperature they're considering their ambient out there. So if this brand and these brands are all in like 85, 90 degree ambient temperature test sites, but this one is taking it to 75 degree ambient temperature sets and getting the same setting. When this one goes all the way up to 95 or 85 temperature, its capacity falls right off the floor, and that's where the problem is. But so not everybody's advertising it on their books and how they're seeing it at the same test level.
And they're all tested at various outside temperatures. The problem is getting that information. If you're not a dealer for a specific brand, you may not be able to get that. Okay.
I have that problem with that's why
Right.
I'm always like, hey, if you use Mitsubishi, I know I can get all that stuff.
Right.
But if you pick some other
Pick something else, I don't know. Yeah. And they won't tell you.
Yep.
They won't even answer the phone.
It's not easy to get some of that information.
Yeah. And you would think they would want that out there so that there's just, it's a black eye to a company if every time their system gets put in, it now seems to be smaller than it should be and it doesn't work well. That's on them. That's not on the HVAC guys. That's not on the designers. If you don't give me the information I need, you can't blame me for the outcome.
And that takes us explaining to the homeowners what is
Right.
actually happening in this relationship here, which is like where
that
you're.
that
so
comes
you have-
back. That comes back on us because the homeowner, they don't want to hear data. They don't want to hear,
No.
this is why this has happened. They say, you're the AC guy, you know better, and why'd you put that in here? And then, as at my end of the company, that I end up buying the custom leave air conditioner and putting the right one in to make them work.
So your biggest problem with this entire industry right now is what?
I guess the part that would get a little annoying is a lot of the equipment that's coming out today, everything is getting more and more. Basically, you're buying a computer that cools air or dehumidifies is basically what it is. And the more technical they're getting, the more the breakdowns, the more the warranties. And I would just say the design of some of the equipment or the engineering of some of this equipment is, the cost is going up, but I think the quality is going down because the breakdowns are going up. In a lot of cases with this newer higher end stuff, you would think because you pay more for it, there's going to be quick parts availability. You're going to be able to fix it when it breaks down. But when this stuff breaks, in a lot of cases, the dealers around here do not carry all the parts, or they don't have them readily available. So your house can go out of air conditioning, and you're going to be, in some cases, I've have to tell people it's going to be 2 or 3 weeks before you get your air back. And in Florida, you're going to get a lot of bad phone calls before those 3 weeks are up with some really mad customers. And you can't explain to them, I'm sorry, it's not my fault, because all they know is the AC guy came out, you put this unit in, and it's broken. Now I'm sitting here with no air. So that the AC guy takes all the blunt from the customer because they won't look at the fact that it's even everything installed correctly, everything done right, you're still going to get these breakdowns. It's just, and trying to explain that to a customer, all they know is you put it in, it's your fault. And you take all the hit for bad engineering, basically.
So, and this is not just to say sympathize with your HVAC contractors. It's also to say this is why you will find not a lot of HVAC contractors are getting on board with what's going on this channel. And even if like you're a good friend and you're on board, you installed the Tiny Lab system, you know about right sizing, you know about testing, and still it makes you nervous to do some of these things because you get that pain immediately. If something goes wrong, you're the one that's actually gonna.
You feel bad about it, or you should feel bad about it. You want to help them. That's why you're in business. You're trying to help people and solve their problems and issues. But when the equipment you have to use, I hate to use this term, but I do it a lot with the customers. I say when it comes down to air conditioners today, maybe the engineering's going to get better down the road. I basically tell everybody as they go to buy it, I said, look, everything I can sell you is a piece of junk. And I said, all I'm trying to do is recommend you the best piece of junk you can buy. That's how I tell them. I said, I am not a salesman. I'm going to be as straight up as I can be with you. I said, almost everything I can possibly sell you from every brand out there is pretty much going to be a piece of junk. I was like, nothing I can sell is going to come, it's going to come with a 10-year warranty on your parts and all that good stuff, but nothing is going to make it 10 years without some major repairs. You're going to have coils, you're going to have motors, you're going to have a lot of issues that are going to go out.
So these guys don't want to name brands because they don't want to get attacked in the suit. I am a Mitsubishi guy, and I've said this to you before, that like, oh, well, what about Mitsubishi? And you've been through their training and you've installed Mitsubishis before. So like, can you give me the feedback on that is included in your list? And the other Asian brands, LG, Fujitsu, Daikin.
Mini splits to me have their right place. There's right places where you can use them, and there's some places where they're just getting used where it's not all the greatest. But I'm doing a lot with Mitsubishi on about wanting to tear them down.
Just with mini splits or with ducted too?
Ducted minis and that.
Okay.
Like, perfect example, I put a ducted mini in just 9 months ago. Statics are right, everything's worked. The guy was super thrilled with it. The thing's 9 months old. I just went to it the other day. Already got a busted evaporator coil. So, unfortunately, in locations with those to change a coil out, in most cases where they had to get it put and everything like that, I basically have to rip the whole air handler back out of the house, change the coil, and then reinstall it again. And since it's in the first year, I just have to take care of it, and that's just part of my thing. But I do an extraordinarily high amount of Mitsubishi, so maybe it's just me, but we do have. There's a lot of areas where they could really do a little better. They have a very, very high coil rate, failure rate to me. I seem like I change a ton of evaporator coils and those things.
It's interesting.
Are you seeing a lot of failures in control systems, control boards?
Yes.
Okay,
Yes.
I think part of the reason for that, I don't see in most of these systems. I mean, Tampa is like the lightning capital of the world. I don't see a lot of lightning protection in these systems as they come from the factory.
Yes, and when they fail, they take out, usually this board will fail, or part will fail on this board, and with the design, it will take out this board, this board, and this board. You'll end up replacing multiple boards, but
Right.
sometimes it takes 2 or 3 trips because they don't really have a diagnostic that you can't test this one unless this one works. And this one, so you may have 2 or 3 trips before you
And
can
you may
figure
not
out
know
exactly.
which one killed which.
Yeah, you can't figure out which, or you might replace this one and it blows this one back up because it was this one.
Right.
So you run into that a lot, and there's not the best training as far as that goes in that department. But an area that I've been finding a lot here in Tampa lately is the Mitsubishi, or basically almost every mini split. I've bring this a couple times now. Their high voltage limits, they have high and lows, maximums you can run your voltage high or low on. Most cases where I'm seeing in Tampa in certain areas is my call just getting real spicy on the voltage, whether they're just crossing the threshold of the maximum voltage that the machine can take coming in from the power grid. And it's hard to get that fixed because, the power companies don't ever want to say their stuff's getting high. So I end up having to put in, we'll go out, the systems will shut down. They'll either blow the boards from too high a voltage, or they'll just go to overvolt, lock themselves out, and then we have to go physically restart them, and then you'll get called out. It'll happen like at night. Every night, we'll run all day, everything will test fine. Night, they lock out. And then you put on you put on a voltage monitor so we can monitor what the voltage is doing over time, and you'll see at night, so it'll be shooting up just over the threshold and shutting it down. But my problem is with the thresholds. Mini splits are narrower and tighter than all the other air conditioners. So like a household air conditioner will not shut down because it can take a higher threshold.
What kind of range are we talking about? 100 to 140? Is that like a...
No, these are all like 240 volt systems,
Okay.
230, 240. But like say you get to 255, 258, you start reaching the maximum that machine's rated for, where a household unit may be able to go up to 265, you have a little bit higher range you can run on the standard residential home units.
Yeah.
Same thing on my schools, or my other, big jobs. I do a lot of 3-phase, 480 and stuff, and certain motors are not rated over like 490 volts, and they'll push it up to 490, but that's within the spectrum, within the margin of error of the power company. But the machine is rated at 460. The transformers all in the state are 480. I don't know why they would rate a machine at 460 when the transformers are 480.
So this again is your point about the engineering. Just
Sometimes
we're not
there's
talking
some-
to each other,
Yes.
and it's not happening on the
Right.
home
Right.
trade team, but also at the manufacturer, the utility, and the electronics.
And I wish the mini split manufacturers would make their threshold of power a little bit bigger so it could match at least the air conditioners, because it's really hard to explain to a customer why I can't make your mini split work because of the high voltage, but I can make your household unit run all day long.
But it's not my fault.
Yeah, it's like it's nothing I can do about it. They just look at you like,
man.
okay, you don't know how to fix this air conditioner. And I'm like, I've got the proof, and then, sometimes I can fight the power company a little bit, and eventually they're like, okay, yeah, we see there's a problem, but
But as long
it
as-
takes an act of Congress to get that
As long
done.
as your equipment range falls below the range that's allowable by the power companies. And a lot of times that may not be dictated by the power companies, it may be dictated by the state, or, what their range of acceptable power is. I mean, it could be as high as 10% plus or minus.
Right.
And if your equipment is 5% plus or minus, then you're kind of hosed.
Yeah.
That's another issue, is the quality of the power. Not necessarily the level of it, but we've got power that's not particularly clean by a lot of our utilities.
Yeah.
So sag surges, spikes, even though they're transients, can have an effect on electronics way out of proportion to what actually happens there.
Right.
And unless you can track that, you can data log all those things. But most companies aren't set up to do that kind of testing. And
Testing.
and it's important. If you're going to pick a fight with the power company and you come in with reams of paper, this is what your power line did for the last 30 days, and this is why it's a problem, then you might get somebody to listen to you, maybe.
It's not easy.
But they don't even have that data. Like often the plumbing utilities and the power utilities aren't actually tracking. They don't have their sensor. So if you have the sensor, you have information they don't have.
Right.
Well, I think the power in Florida has always been pretty dirty. I mean, they've always had issues with power. I just think as the machines are getting newer and newer and this technology is getting higher and higher, the threshold of dirty power it can accept is getting lower and lower.
Get more sense.
And now the problems are starting to show up everywhere as this new stuff's coming out. Like, hey, this stuff doesn't work in Florida, or we're having just tons of problems. And, they're not going to say, yeah, this is all us, because they're going to probably try to clean up the power. Yeah.
So hearing you describe this, and you being exactly the kind of HVAC contractor that we need, at what point does this business become unprofitable for you and you just say, you know what, I quit, I'm going to go work on airplanes again?
There's many days where you feel that way, because I see the new stuff coming out, and I see probably the nightmare of warranty problems and breakdowns that are coming, and there's just so many faces you're going to face of just aggravated, upset people that are going to blame me for this all day long, and you can't explain to them that it's not you, it was how this thing was built. It gets to be enough sometimes when you do get that way. You're just like, you know what? Why do I keep doing this? Maybe we should just move on and find something else, because I take it kind of personal when I get hit and get blamed for stuff that I really have no control over.
Like, how big can your shoulders be?
Yeah, exactly.
That's
well, you could be an HVAC contractor, and you're not. And I could be, and I'm not.
Yeah, and
I don't want to be. I mean, that's the thing, is when you know enough about it.
It could be tough.
And I think that the answer ultimately is we're going to have to charge more. Like, Brad's going to have to make it worth his while to do all that extra pain in the butt stuff. And so it gets even more expensive on top of the equipment.
And prices are already, in my eyes, too high.
Just like
to me,
housing.
they're just ridiculous. The cost of equipment has gone up so fast.
Yep.
I mean, especially since COVID. It's just, I keep thinking maybe we're going to slide back and get a little better number here and there. It's not. Every time I turn around, it's like 4 more percent, 5 more percent, 6, and it's just boom, 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 and it's just up.
Right.
And this new stuff coming out, when it goes to variable frequency drive compressors, the average household change out is going to be so high, it's going to darn near take a loan to get it done. I mean, right now,
So this is a conspiracy by the banks.
I don't know. I just know the numbers are going to get so high where you're going to think you're buying an old car back in the day. It's not going to be that affordable. I mean, I'm in the business, and I'm dreading to have to change my own. That day's going to come, and I'm going to have to buy one of these things.
Let's talk about something nice to change. We'll talk about dehumidification, because this is a big topic. I think so. I recently had a client in Arizona, in Phoenix, and everybody thinks, oh, it's dry there, but it's 110 degree temperature design temp, but the humidity design temp is 80, and it is too wet in Phoenix. You need a dehumidifier if you're really going to handle that, because you're not trying to deal with the 110. You're trying to deal with when it's really wettest. So here, you guys have this all the time. Yeah. Everybody basically needs dehumidifiers. Are you finding, when you go into homes, do they have a dehumidifier already?
Not many.
Okay.
More companies are they're trying to base everything on trying to make the air conditioner do it. And that's why more people are trying to push those variable frequency drives, and it does help with it. But if you don't have a house that's already ready to accept it, because going back to the old school guys, we still do a lot of these old homes, and to try to take a 30 or 25-year-old home that was built and still has its original ductwork from 25 years ago, back in the day, the old school guys, checked their little calculator out, and they just went to 1.1 statics, and that's where they set the ductwork up at. So there's not any old duct system you look at, almost going into it, you're already going to know your statics are over what the machines are even rated for to get your efficiency. And trying to tell a customer that, and just say, listen, I can't install this machine because this ductwork won't accept it unless you're going to upgrade the ductwork to accept it. You're just wasting your money. And then the next thing they do is call the next guy and says, yeah, I'll put that in there for you.
Sure. So so you've been installing some dehumidifier bombs for schools by hot running systems yourself, and I want to talk about that in a minute. Do you find people having dehumidifiers, people who are smart enough to know that they need testing?
Yeah, well, first you have to find the people smart enough to know they need testing. Most people don't. And when I come in, like I'm going to a house Monday, and we're looking at a future change out, their systems are running now. Okay, which is a benefit, really. It is a benefit, really, because now I can test that system and see what the ductwork's doing now with what's there. I can measure airflow, I can measure static pressures, and I know what we're going to walk into with ductwork. So you may offer ductwork for that system as this is something you have to do, and here's why you have to do it. But a lot of times, the kind of testing that you need to do is an added cost to them, and an added cost to them is money out the back door, not money in the front door. So they say, well, maybe we really don't want to do that. And that, yeah, you have to tell them that if you don't do the testing, we're not going to know. So when we put it in and it doesn't work, I didn't do that. You made that decision. But most places for me, I don't even have plans. I don't have even a floor plan generally. What I get is probably what the property appraiser has for that horrid drawing. And so I have to go in and develop a floor plan. And this takes time. I can spend 3-4 hours in a house just getting the information I need to make a reasonable design for that house.
And that is why free manual J calculations can't possibly exist, because that 3 to 4 hours is required on an existing home if you really want to know.
Yeah. Quick Model 3D. They offer a service like that, but what they do is they send the questionnaire to the homeowner. And the homeowner has to go in to insulation levels and all this other shit. Things that, I mean, there are people motivated to do that have a little bit of knowledge, but for the most part, I see that as maybe not working quite as well as they would hope.
Oh, interesting. That's, by the way, if you want to try that, it's DIYloadcalcs.com. That's a friend of all of ours, Russ King. So, okay. So dehumidifiers.
Yes.
Have you been using, there's different ways to ventilate a home with dilution air, which is just one of the 5 factors. It's the number 4 factor. Not everybody needs it. You get a lot of other things going on. I've got a video on that if you want to see. But are you ever using ventilating dehumidifiers to bring in fresh air from outside?
I have a few that have gone that way.
How do you like it?
I like it, but there's some issues as far as ducting that can be a problem. I've run into systems that are ducted like backwards, just doing weird stuff.
Yeah.
And then with the ventilating part, I mean, nice short runs, don't use flex duct unless you absolutely have to, because it's just too restricted. You've got, in most of these, that ventilation air opening is 6 inches, and it's not a big fan. You put too much restriction on that fan, and you're just not going to get the volume of air that you need to ventilate the house.
It'll be louder.
Yeah.
My concern about this, and there are people in Florida who ERVs aren't necessarily the answer for everybody. They're expensive. You're pointing out, just like we have with other brands, hard to get parts, hard to replace, hard to repair. But ventilating dehumidifiers are an option where you can bring that ventilation in through a dehumidifier coil first. I think there's not enough ventilation capacity in these things to grab all the humidity in Florida in one pass. There's that. Number 2, you have to keep the compressor on 24 hours a day. This thing's bringing like 75 CFM from outside. And that's basically what you need in most homes. So it's running 24/7.
Right.
Is that
so the life of them is very short.
Okay.
Or somebody makes the mistake and puts an HRV instead of an ERV.
Yes.
Don't do that. Don't do that. Anybody's watching.
You don't want those in Florida.
And we have a house that we've been working for a while that had 2 of them.
Oh, 2 HRVs.
But they thought they got ERVs.
Oh.
Yeah, they were sold ERVs and HRVs got installed.
Yeah, right. And I mean, you know, I've had clients where people had a cut sheet of what like is supposed to be ordered, and then they look at the stuff that's in the garage, and it's like none of these product matter. They don't match up. So you just got to check this stuff because it's hard to do. So tell us about your dehumidifiers that you've been building for schools.
Well, that's not that they're new. This is just you can order.
I know, but it's cool. You're cool.
Everything commercially already has this, and I actually loathe it's Reheat Dehumidification, where we're using a reheat system. Commercially, they're available everywhere. I mean, we can get them all the time. It's been around for a long time. It's just becoming more popular.
And this is basically using an air conditioner to cool and dry, and then just heating it back up. But in residential, we use heat strips to do that, which is electric.
Yeah,
you're not using that.
No, that costs a fortune. You just as soon as you fire up those heat strips to try to dehumidify, your power meter just. I mean, it'll cost you a fortune to do it that way. You're better off to put in a dehumidifier in that case. But I'm starting to see it right now. It's not quite available to the residential side, but they're starting to build split system reheat systems built into your standard household unit.
With gas as the heating fuel?
Look, it's fuel. It's just Freon. It's the same system. It's almost like a heat pump. You know, a heat pump reverses.
So they're putting part of the condenser coil inside.
Yes.
Instead of
you put a separate coil on the inside at the discharge, and basically your AC coil is still running at full capacity and pulling the moisture off. but you don't want to overdrive the temperature in the room, because if you just keep it going, it's just going to get colder and colder. So then the condenser has a valve outside. It reverses the flow up to that top coil, and we heat the air back up with maybe only a 3 or 4 degree drop in temperature. So you can sit there and continue to run, and just basically turns the machine into a great big dehumidifier.
That's interesting. Dehumidifiers have like a 15-degree temperature rise because they're a closed system. You're saying that this can actually do a lot better because we've got 3 things going on.
Well, they have the ability to set that. Depending on where the calcs and where the numbers are. I mean, they can go hotter, it can go colder. It's just how much heat they put into that coil, and then how much they run the fan, because it actually uses that coil and the outside coil, and they can control the temperature of that by running the fan. Whether they want to go colder or hotter, you just run the fan a little bit more, and you can move that temperature up or down, or you modulate it with a modulation valve, and then only so much goes this way and so much goes that way. And can still
there's
control
control wise that very flexible that way, because you can control with with the EEV, the hot gas that goes to that indoor coil. EEV, electronic expansion valves.
Okay.
Yeah, they use them a lot in mini splits. I think you use them almost exclusively in mini splits. But you have the opportunity to control that split of gas by that, and that can allow you to moderate the outlet air temperature to a point where it's not crazy hot coming out of the ducts or crazy cold coming out of the ducts. And you can do that, so you can dehumidify without the overcooling that you get with variable systems. They can dehumidify to a degree, but it requires that you overcool the space. And usually that 2 or 3 degree difference to some people can be they set the temperature in the house at what they want the house to be. They don't want it to be 3 degrees cooler because they're constantly dehumidifying. And if they oversize these variable systems, that's where they end up. That's Nico's house, where they end up with the system rolled back because it can meet the temperature really easily. So it's bouncing on that humidity set point. Okay. The gas reheat, they've used that for years in dedicated outside air systems in bigger buildings, where they have a system set up that just brings in ventilation air. And what it does is it's basically an air conditioner with hot gas reheat, and they can do that. So that works really well there. And they used to try to do this with enthalpy control with economizers. It's colder outside, we can bring air in. Well, that's nice unless it's colder out because a thunderstorm just came through. And they don't know, the equipment doesn't know that. So you just suck in all that thunderstorm air into the building, and now you got to fight for the rest of the day to get that water back out. So there's issues with that. And then sometimes the ventilation can be an issue as well, unless you have some kind of enthalpy sensing on the inlet side of that. I mean, there's conditions where you don't want to bring in the outside air, and it doesn't matter that it's more efficient to do it with an ERV or whatever. But then with the ERV, once you put that in, you know you're going to need a dehumidifier.
Yeah.
That should be almost sold as a package.
Right.
My worst case scenarios are, like, say the building was built and it was engineered to spec for the unit that's supposed to have all that stuff in it, but they built it and didn't put that on. They put something lower end on without the reheats, without all that stuff. So this goes more in the commercial side more than the residential side. But then in a commercial building, you got to worry about CO2 because you got too many people breathing out. You got to make sure that stuff gets flushed out with fresh air, and you got to keep it dry so you don't flood the building. So you've got to, if you don't have a way to get that humidity out, you've got this massive machine in this little area with nobody in it, then your humidity skyrockets to 85%, 90% in these classrooms, and then you get mold, mildew, all the problems.
And I put my kids in this perfect little house for some of the time, and then I send them to a building like that, and I freak out thinking that.
Yeah. So I mean, that's why as soon as they see the problem, they'll bring us in, and then we start doing monitoring the classroom, seeing what the CO2 levels are. They're supposed to be under control, but they're not under control, and then we just start going through the process. What can we change? Can we work with what's here, or do we have to make our own stuff? So nobody really makes their own reheat systems and puts them in. I'm crazy enough to try it. So
Awesome. So hopefully we'll go visit the school and see one of those.
I've been through it.
Tim DeStasio is doing kind of an experiment in his house where he's running half of the summer with his a Bosch doing its reheat function,
right,
and then the other half with his ventilating dehumidifier.
Right.
And he's comparing prices and seeing all that work. It'll be interesting to see how that all works out at the end.
Yeah, we won't give any spoilers, so we'll have him on to talk about that.
Yeah.
He said that he wants to do a video.
Yeah.
All right, awesome. So big picture, I think that the message that I'm taking away from this is what you guys are seeing in Florida, in one of the most intense climates in the country, is that people have not yet decided that they need dehumidifiers, even though you guys know that they do.
Yeah.
They have not yet decided they need fresh air, probably because they're not airtight enough yet. And when they do start getting more airtight in Florida, you guys rolled back the code to 7 ACH50 because airtightness here is that liability. You get all those side effects of what you were just talking about.
Yeah, 7 is the code now. We tried to get it to 5 when it first got put in the code, and there was so much pushback that they said, no, 7 is good.
Is that just contractors like HBAs and stuff?
Yeah.
Okay.
It's the same argument they've done with everything since sheetrock. If we have to do this, we'll never build another house. So,
And I mean, like, look at this guy. He's still in business, and he takes all this crap all day long. So they could take a little bit more. The HVAC guys shouldn't be taking all of it.
no, they have their part in the party here. So,
That's right. All right, cool. So you guys stay tuned for more HVAC developments. Make sure that you support your local HVAC contractor, support your local testing contractor. Like, subscribe, tune in next time.